When you have a system of two linear equations, two lines, there are three possible outcomes. They can cross, they can intersect, and that means the system has a solution. It just has one solution. However, they might be parallel lines. They might never touch each other, never cross. If that's the case, the system has no solutions, and we call that an inconsistent system of equations if there are no solutions. There's one other possibility that I don't have a picture of here. It's when the lines are right on top of each other. You have two equations that really simplify to the same thing. If that's the case, we call the system dependent, and it's an infinite number of solutions because every single point on the two lines matches. So the number of possible solutions for a system of two linear equations is either 0, inconsistent, 1, consistent, or infinity, dependent. So let's look at this one. We have these two equations, y plus 3x equals 3 and 2y plus 6x equals 12, and we're supposed to say which graph represents this, what the solution is if there is one, or if there's no solution. For me, the easiest thing to do is to put both of these equations in slope-intercept form. Then you can compare the slopes. If they have the same slope, they're going to be parallel and there will be no solution. So let's check that. I've got to subtract 3x from both sides. On this one, I would get y equals negative 3x plus 3. On this one, I've got to subtract 6x. I would get 2y equals negative 6x plus 12. Then I've got to divide both sides by 2. And I'll put it right up here next to this other one. I get y equals negative 3x plus 6. Aha. So my first equation has a slope of negative 3. My second equation has a slope of negative 3. So they're either parallel or they're the exact same line. I know they're not the exact same line because the y-intercept is different. A positive 3 for this one, a positive 6 for this one. So there's no solution to this system of equations. Let's see if we can pick out which graph it should be. We need y-intercepts of 3 and 6. This one looks like it has a y-intercept of something smaller than 3 and 6, maybe 1 and 4 or something. This one looks like 3 and 6. And the others are pictures of systems that do have a solution, so not this one. So it looks like A is our answer in this case. Let's try one more. All right, it says determine the solution to the system of equations and state if the system is inconsistent or dependent. Okay, so again, I want to just change these to slope-intercept form. In this first one, adding 3x to both sides is going to put the y alone on the left, so that's what we want. So that's going to be a positive 3x plus 3. This one, let's see, I'll have to add 9x to both sides to get the y term alone here. So that's a positive 9x plus 18. Now we need to divide by 3. So I'll put it up here again. We're going to get y equals 9x divided by 3 is 3x. 18 divided by 3 is 6. Looks very similar to the last problem. We have similar slopes. They're both positive in this case. We have the same slopes, not similar, same. And then different y-intercepts. So these are parallel lines. The system is inconsistent. There's no solution. And let's see if we can just find the lines that match. So we're looking for 3 and 6. Yeah, this one looks like 3 and 6. This one looks like something smaller than that. Maybe 1 and 3 or 1 and 5 or something like that. So it looks like it's A again. So that's a little bit of work with inconsistent solutions to, or no solutions, inconsistent systems of equations.